All right, so today we're going to continue doing the chemical equation stuff. And so let's start by reviewing real quick. All right, so what we're going to do is we're going to write a chemical equation. The positive one is Mn4 plus, and we are going to be reacting that with O2 minus. Okay, so O2 minus. All right, so if you guys remember, we want to balance out the positive and the negative energy. And so if you guys take a look at this, hopefully you're able to see that you need 2 oxygens in order to balance out one of these guys, right? Because if you have 2 oxygens, you have O2 minus twice, and that'll balance out the positive 4. So what we're going to do is we're going to put a 2 in front of oxygen and a 1 in front of Mn. Okay. And again, the reason we do that is to balance out the positive 4 with negative 4. It's pretty much what we've been doing. All right, so what we're going to do is we're going to put them together to make our ionic compound. And so our ionic compound is going to be made up of 1 Mn. So we put Mn right there. And then you need 2 oxygens. So we're going to put O2. So there you go. That's going to be our ionic compound. These guys combine together to make this chemical right here. So just to kind of review what we've been talking about, we've talked about elements since the beginning of the school year. And elements are the stuff that we find on the periodic table right here, right? And molecules are when we put those elements together and make up bigger compounds. So like H2O, you know, the thing that we did in the warm-up, this would be a molecule, MnO2, things like that. Okay, so today what we're going to do is we're just going to review how to read these chemical equations to count the elements inside of it. And then we're going to learn a new way to count the elements. So let's take a look at number 1. I want you guys to copy down this formula onto your notebook, C17H21NO4. Okay, that's the chemical formula for cocaine. And what we're going to do is we're going to count how many of each element are inside of cocaine. Okay, take a second to copy that down. Okay, so if you guys remember what we've been talking about, the number behind the element tells you how many of that element you have, right? So if you take a look at cocaine's formula, we have 17 carbons. The capital letters are the element. So cocaine has 17 carbons. The next element is hydrogen. If you guys look, it has 21 hydrogens. So we have 21 hydrogens inside of cocaine. If you look at N, there's no number. If there's no number, that means you have 1 of that element. And obviously for oxygen, you have 4. All right, any questions about that? Hopefully it's not too bad. We've been talking about this for a while. Okay, so I'll give you guys a minute now to work with the person next to you. I want you to copy this formula right here on your notes for number 2. This is the formula for vinegar, and I want you guys to figure out how many of each element there are in that molecule. So I'll take a minute. This one. Okay, so if you guys take a look at the formula for vinegar, you guys should see there's a carbon here, and it's separated, but there's another carbon here. So you're going to have a total of 2 carbons. Okay. So sometimes you'll see formulas where things are split up, but all you got to do is just add them together, okay? Take a look at hydrogen. You got 3 here, and you got 1 over here. So you have a total of 4 hydrogens. Okay, and then lastly, you have an O here, so that's going to be your oxygen. So you got 2 oxygen. Okay, so the point of that problem was just to show you guys, if things are split up, you just need to add them together. That's how you get, that's how you count the elements inside that molecule. Okay. Go ahead. I don't know. I didn't see it. You can take a look though. All right. Let's go to the new stuff for today. So today we're going to be looking at these molecules that have these parentheses. Now, when you see these parentheses, I know it looks kind of scary, but what it's basically just telling you is that you have multiple of everything that's inside of the parentheses, okay? So here we have the formula for estrogen, which is the female sex hormone. But if you guys notice, all of this is inside of the parentheses, right? And if you notice, there's number 2 on the outside, right? What this is telling you is that you have 2 of everything inside of this parentheses. So you can rewrite this formula just like this. This is the same thing as C9H12O2, but you have it 2 times. You can just write it next to each other 2 times. C9H12 and O. Oops. So if you notice, all we're doing is writing the formula twice like that. Okay, that's what the parentheses mean. It's nothing, it's just a fancy way, kind of a lazy way of writing these formulas. It's just to show you have 2 of everything in there. Okay. All right, so if we wanted to do the same thing for, or if we wanted to count up the elements, we can just count them up real quick. You have 9 carbons here. So you got 2 of them. So you'll have a total of 18 carbons. You have 12 hydrogens here, 12 hydrogens here. That's a total of 24 hydrogen. And then you got 1 oxygen here, 1 oxygen here. So that's a total of 2 oxygen. Okay. So that's pretty much what those parentheses are. We're going to be using the parentheses a little bit later in the lecture, but it's just telling you that you have multiple of whatever's inside of the parentheses. Okay. Any questions about that? Or should be, hopefully it's not too bad. Just multiply everything inside by the number outside of the parentheses. All right, so let's see if you guys got it. So I'll give you guys about a minute or so. I want you guys to copy down this formula and figure out how many of each element there is in testosterone, which is the opposite, which is the male sex hormone. So take a second, see if you guys can count up how many of each element there are in testosterone, and then we'll go over it together, okay? Okay, so like I just said, you want to multiply everything inside the parentheses by the number on the outside. So if we rewrite this formula, we'll have C9, H14, and O, but since there's a 2 on the outside, we just write that 2 times. So C9, H14, and O, okay? And don't forget this C all the way at the very end. Okay, so these parentheses right here, we can just rewrite it as this section right here, just everything on the inside 2 times, okay? All right, so from there, all we got to do is just count them up, and then we'll be all done. So if we take a look at the carbons, you guys should see that there are 9, 9, and then 1. Whoa. Okay, so that's 18 and then 19. So you should have 19 carbons. There's 14 H's 2 times. That'll be 28 hydrogen. And then lastly, there are 2 oxygen. Okay. So I know that can be a little bit tricky just with all the different numbers, and then now there's parentheses. But just remember, the 2 on the outside of the parentheses just means you have 2 of everything on the inside. If it was 3, you would have 3 of everything on the inside, and so on and so forth. Okay. All right, any questions about the parentheses? We'll be using them with the chemical equation stuff that we've learned so far in just a second. But if there's no other questions, we will move on. All right, so today we're going to be using these parentheses with the chemical equations that we've been doing. So you guys don't need to write this next part down. I'll tell you what's important. But up until this point, we've been learning about things called monatomic ions. So ions are things that are like +1, -2, things like that. So if you guys look, these should look pretty familiar, right? Na is +1, O is -2, so on and so forth. But today we're going to be talking about something called polyatomic ions. So I do want you to write this part down right here. And polyatomic ions are molecules. They're groups of atoms. When they stick together, they want to be +1 or -1 or stuff like that. And as you guys copied that down, I'm going to pass out a handout. This is a new chart that you guys can hold on to. that has all the polyatomics you'll need to know for this class, okay? All right, so the handout I just gave you looks something like this. If you guys notice, there's like two parts to it, right? There's this part up here, and then there's this part down here. We're only going to be looking at this top part for today, okay? So you can ignore the bottom part. So if we take a look at this top part, these are polyatomic ions. And if you guys notice, all of these guys have a positive or negative charge, right? If you guys take a look, ammonium right here has a +1 charge. Carbonate has a -2 charge. Phosphate is -3. You guys can all see that, right? So these are molecules that when you put them together, they like to have a positive and negative charge. Now, I do want to clarify a couple things before we move on because people get really confused because there's like multiple numbers that we're working with now. So if we take a look at NH4, this 4 down here has nothing to do with the positive energy, okay? It does not mean that this compound is +4, okay? This compound is +1. We only look at the thing that's up here on the top right. This 4 is just telling you that if you have a nitrogen and if you have 4 hydrogens that are connected to it, okay, this whole thing, it wants to be +1. Okay, that's what that 4 means. It's just telling you that it's made up of 4 hydrogens. The positive and negative energy has nothing to do with the 4. Okay, I want to clarify that because the number down here confuses a lot of people. Okay, so for today, you can just kind of think of these numbers on the bottom as stuff you copy down, but all you really care about are these numbers at the top right, the positive and the negative energy, okay? And these guys work exactly the same way as all the other ions that we've been talking about. So for example, this guy is +1, right? That means it can balance out the negative energy just like any other +1 can. So for example, if we had Na plus and Cl minus, right? Na can cancel out Cl in order to make NaCl. Okay. Very similarly, since this guy is +1, if you have NH4 plus and you have Cl minus, this guy can cancel out Cl minus to make NH4Cl. They work pretty much exactly the same way. The only difference is it's just more stuff to write. Okay. All right, so that might be a little bit confusing. So we'll do a couple practice problems before I have you guys start the assignment. But for today, we'll be using this table a lot, so just make sure you have it handy, okay? All right, so what we're going to do is for the remainder of the class or the lecture, we're going to be writing the balanced equations, okay? So we're going to be doing number 1. So for number 1, I want you guys to copy this down. We have Ca2+, and we're going to be combining it with the chemical nitrate. Okay, so just let's copy that down. For number 1, copy down Ca2+, and we're going to be combining that with the chemical nitrate. All right, so if you take a look at nitrate, nitrate is on the chart that I just gave you. So let's take a look at nitrate. Okay, nitrate is right here. And nitrate's formula is NO3, and it's -1. You guys all see that right here? So for our notes, we're going to be writing down that calcium is going to be reacting with NO3. And remember, this is -1 because the 3 is down here. It has nothing to do with the positive and negative energy. Okay, so this is nitrate. All right, so if we take a look at this, this is +2 and this is -1, right? So obviously we have more positive energy, so we need to balance it out by adding some more nitrate. Now nitrate is -1, right? So we're going to need 2 nitrates in order to balance out 1 of the calciums, because +2 and -1. Hopefully you guys are able to see that. Okay, again, we're doing the same thing as before. We're just balancing the positive and the negative energy, +2 and -1. All right, so we're going to put them together. And all we got to do is write down these two things and just the correct number. So Ca, we only need 1 Ca, so we're just going to write Ca, no numbers behind it. And we're going to need nitrate, NO3. But if you guys notice, we need 2 of them, right? But if we just put a 2 by itself right here, it looks like 32, right? Which is incorrect. So that's why we use the parentheses to show that we need 2 of these nitrates. So it'll be Ca parentheses and the NO3 2. So that's what the parentheses are for. It's to tell you that you need multiple of this whole thing right here. Okay, but other than that, it's pretty much the same thing that we've been doing. All right, so we'll do number 2 together as well, just so we get a little bit more practice. But before we go over it, I want you guys to look at your chart right here. And I want you guys to write down the formula for ammonium and for phosphate on your notes. That's going to be number 2. So I'll give you guys a minute. Copy down ammonium and phosphate, and then we'll put them together and write the reaction. Take a second to do that. Okay, so if we take a look at the chart, we have ammonium here on the top left. And if you notice, ammonium is NH4 plus. So we're going to copy down NH4 plus. That's the formula right here for ammonium. So NH4, and the charge is +1. Okay. Okay, let's take a look at phosphate now. Phosphate is also from the chart right here. And if you take a look at phosphate, phosphate is right here. It's PO4 3 minus. So we're going to write down that it is PO4 3 minus. Okay, hopefully you're able to see it right here. And so what we're going to be doing is we're going to be combining ammonium and phosphate. Same thing as before. We're going to balance out the positive and the negative energy, and we're going to create the ionic compound. So if we take a look at it, you guys should be able to see that we have more negative energy, right? It's -3. Then we have positive energy, which is +1. So we're going to need 3 ammoniums in order to balance out 1 of the phosphates, because you need +3 to balance out the -3. So if we put them together, you're going to make 1 compound. And now we just need to put them together. So NH4 is going to be the +1. We need a total of 3 of these. We need 3 of the whole thing. So we're going to put the whole thing in parentheses to show we need 3 of them. And then we're going to write PO4. Okay, and there you go. That's your chemical equation for this one right here. Okay, so hopefully you guys are able to see this is same thing that we've been doing. It's just balancing the positive and negative energy. Again, the only difference is that now we're working with these polyatomic ions from the new chart, and the formulas are a little bit more complicated. But again, just look at only the positive and the negative charges. It'll help you balance them out. All right, we're going to go over one last problem, and this is the last type of problem that's going to be on your assignment. And here, I'm giving you the answer to the problem, and you need to write the rest of the equation, okay? So I want you guys to copy this down on your paper real quick, and then I'll show you guys how to write the rest of the equation with this right here. So copy this down, give you guys like 30 seconds to do that, and then we'll go over how to break down that problem, okay? All right, so here we have this chemical right here, and we need to figure out what it breaks down into. So if you take a look at this formula, you're going to see that this thing contains nitrate, right? NO3. We learned about this a second ago. Okay. Now, if you take a look at this, there are 3 nitrates. So this chemical breaks down into 3 separate nitrates. And again, it's right here. We got it from this problem, nitrate. And each of the nitrates is -1. It's -1 for each of them. So again, we see nitrate here as the negative ion, the anion, and there's 3 of them, and they're all -1. If you guys look on the other side of the equation, there's Sb, and there's only 1 Sb because there's no number. And so what that means is one of these Sb's is balancing out all of the nitrates. Okay, since all the nitrates are -1, we have 3 of them. So -1, -2, -3. So that means Sb has to be +3 in order to balance out these nitrates right here. So again, you want to start with the polyatomics. It's nitrate. It's -1. And if you're confused where we got nitrate, nitrate is right here in the chart. NO3 minus. Okay, the chart that I gave you. And they're -1 each. So SB needs to be +3 to balance it out. All right, so now we can just finish up the equation. Okay? So all we have to do is write down that we have 1 SB3 plus, right? We only have one of them right here. We're going to be combining that with 3 different nitrates, so 3 NO3 minus, and it's going to make 1 SB NO3. Okay, that's pretty much it.